Hi, ladies and gentlemen. I hope everyone is doing well today. Today we are taking a look at covalent bonding. Right in the beginning, there's some terminology, so it starts off by reminding us what an ionic bond is. Remember, an ionic bond is a metal and a nonmetal. So if we look at a periodic table, if we come over here, on every periodic table there is a light line right here. I bolded it in so that everyone can see it. On this side of the line is nonmetals with a negative charge. Over on the other side are all metals with a positive charge. The only thing on the left side of the periodic table that is a nonmetal is hydrogen. It is also one of the only nonmetals with a positive charge. So next, it tells us what a covalent bond is. So a covalent bond is a bond between two nonmetals. So you can recall that an ionic bond happens because you have a positive attracted to a negative and opposites attract. In a covalent bonds share electrons. All nonmetals are very close to filling in the octet. Because they're so close to filling in the octet, lots of time nonmetals will just kind of be like, hey, let's share electrons. That way we all have a full shell and everybody's happy. So that's why covalent bonds share electrons. One thing to remember is some language. So on your definition sheet, you can write down what a covalent bond is, bond between two nonmetals. You can now know the difference between a compound and a molecule. Compounds simply have an ionic bond, so that means a metal and a nonmetal. So a compound is an ionic bond, which is something from the left side and something from the right side bound together. A molecule is something that has a covalent bond. So then that would mean you have two things from the left side of the periodic table bound to each other. We would call that a molecule. Um, the largest class of molecules is organic molecules, and anything that's organic contains carbon. So if you see carbon anywhere in the formula, then it is organic. So carbon equals organic. So next, question one. So question one is using what we know to identify stuff as ionic or covalent bonds. So that's what we can use the periodic table. If you have something from the left and the right side, then it is ionic. If you have two things from the right side, then it's covalent. That is how you determine the bond. Next, question two. So question two is telling us that ammonium nitrate is an ionic compound even though there is not one metal in there. You have to remember that we have an ionic bond as a positive and a negative. So what I want you to do is compare the charges of ammonium, compare the charges of nitrate. Is it still a positive and a negative? Next, question three. Question three, we're circling molecules that are a molecule. Remember, molecules are covalent, so anything that is made up of two nonmetals. So if it's made up of two things on this side of the list on the periodic table, then it is a molecule. And then next, remember which of question three is organic. Remember, everything that's organic contains carbon. So that should get you through the first page. Remember, pause it right now to work on the questions. If you get stuck, circle it and make sure to write down why you got stuck. That way when you come to class, I know exactly how to help you. So next, we are looking at some stuff about naming covalent compounds. So when we name covalent compounds, we use prefixes. When we are looking right here, we can see how to use the prefixes. So the first thing to do is to figure out the prefixes. So I kind of highlighted the prefix and the subscript to help you. So if you see here, the subscript is 2, the prefix is di, so we know that the prefix di means 2. Same thing with oxygen. We have tetraoxide, we have 4 oxygens, so that's how we know the prefix is tetra. So now you guys can do the same thing, analyze the subscript compared to the prefix. It will help you determine what all of the prefixes are. So a couple things, we are going to work on naming covalent compounds. So I just got to fix my camera a little bit so you can see. All right, so a couple things that I wrote down to help us when we're naming. So if we look at the first example, we have dinitrogen tetraoxide. So naming covalent compounds I think is a little easier because you're kind of just telling me exactly what you see. So if we look at the first name, dinitrogen, di is 2, so you're telling us 2 nitrogens. Tetraoxide, you have 4 oxygens. So you're just telling me 4 oxygens. So one thing you'll notice is that when you look at all these examples, that then you never change the first atom's ending. Even though it's a negative ion, we leave it the same. We do not touch the first atom's name. Next, in the first atom only, we use a prefix if it's greater than 1. So if you look at all the other examples, you would see here that when the prefix is 1, we decide not to use it. So only when the prefix is greater than 1 is when you use a prefix on the first name, the first atom. So that's why we see it's dinitrogen. Every other case, there's no prefix, and it's all because all of the subscripts are 1. And then we use the prefixes to tell us how many of each atom is present. So then you would see here we have 6 fluorines, so the prefix is hexa, 5 chlorines, penta, 3 oxygens tri, and then 1 oxygen mono. As you can see, you're literally just using the prefixes to tell me everything that's present. So if we looked at the first case, we could look down here at A. So we're looking at A, we have nitrogen. We never change the name of the first one, even though it's negative. Remember, never change the name of the first. How many nitrogens do we have? 2. So we use the prefix di. So it's dinitrogen. Next, we have oxygen. We have 5. You didn't figure it out yet, but the prefix for 5 is penta. So then we write pentaoxide. We are still going to change the name of the second one. We are still going to drop off the ending and add "ide." So again, that's kind of how you do covalent bonds. You use your prefixes to just tell me exactly how many are present. And then now we are on the last page. So the last page, we are looking at empirical formulas versus molecular formulas. So this is when we simplify our fractions or our subscripts similarly to how we simplify fractions. And so we've already been kind of doing this, we just haven't given it a name yet. So the empirical formula is the most simplified ratio of the elements in the compound. So that's like after we reduce, we call that the empirical. The molecular formula tells us exactly how many of each atoms are present in the compound. So that's the exact number, that's precisely how much you have without reducing. Remember, we care more about the ratio of elements, so you do have to remember to simplify whenever you can. So question 7 is just math. So if you could reduce these fractions, what are you going to reduce them to? Question 8. So question 8, we're comparing molecules 2 and 4 in the table. How is 2 similar to 7A? How is 4 similar to 7B? So what you should do here is compare the numerator and the denominator to the subscripts. So if we were looking at molecule 2 is C4H8. What do you notice about the subscripts that you notice about the fraction? Question 9, empirical formula. Just look up the definition up front. Question 10. So question 10, 11, and 12, we're thinking about empirical formulas and molecular formulas. So when you're thinking about this, so I want you to think about 4 over 8 and 8 over 16. Both of these reduce to 1/2. Are you able to take 1/2 and figure out if it was 4 over 8 or 8 over 16? Is that possible to do? So then that will help you with 10, 11, and 12. And then lastly, question 13 is just to practice reducing some of the formulas. So when we reduce, remember we divide both subscripts by the same number that they're divisible by. Most cases you're going to divide by 2, 3, or 4. You're really not going to have to go much higher than that. So those are always a good place to start with. So start by dividing by 2, dividing by 3, dividing by 4, and seeing if you get whole numbers and they are as low as they go. Remember, circle any questions if you have them, write down why you need help, and then we'll take it from there when you come to class. I hope everyone has a great day.